Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 20 to the power of x is equal to 16 to the power of x. So, to solve this, I'm going to first start by dividing every term with 16 to the power of x. So, these two cancel out my right-hand side. So I'm left with 25 to the power of x over 16 to the power of x minus 20 to the power of x over 16 to the power of x is equal to 1. From here, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 25 to the power of x over 16 to the power of x turns into 25 over 16 to the power of x. And 20 to the power of x over 16 to the power of x turns into 20 over 16 to the power of x. Now, 25 over 16, I'm going to rewrite as 5 squared over 4 squared. And 20 over 16, that just simplifies to 5 over 4. From here, 5 squared over 4 squared is the same thing as 5 over 4 squared. And now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 5 over 4 to the power of 2 to the power of x turns into 5 over 4 to the power of x to the power of 2. And from here, I'm going to let 5 over 4 to the power of x equal to the variable y. So now I have y squared minus y is equal to 1. And this means that y squared minus y minus 1 equals 0. So I get two values of y. If I plug this into the quadratic formula, I get y is equal to 1 plus the square root of 5 over 2, and y is equal to 1 minus the square root of 5 over 2. So recall how 5 over 4 to the power of x is equal to y. Well, if 5 over 4 to the power of x is equal to y, we can't make this equal to a negative number because you can't take the power of a positive number and make it equal negative. So this is my equation here. And if I take the log base 5 over 4 on both sides, I get x is equal to log base 5 over 4 of 1 plus the square root of 5 over 2. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12 because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048, and 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry. All of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now, I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432, and I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.